Chapter 5, Lesson 6, Coordinate Grids. Our content target. Students will understand that you can find locations on a coordinate grid. Our language target. Students will show their understanding of a coordinate plane by plotting coordinates and their opposites on a graph. So identify points in ordered pairs. A coordinate plane is formed when the x-axis and the y-axis intersect at their 0 points. The axes separate the coordinate plane into 4 regions called quadrants. You can use the location on the plane or use the x-coordinates and the y-coordinates to identify the quadrant in which a point is located. So as you can see, it has been divided into 4 parts. Quadrant 1 is a positive positive. If both numbers are positive, you're up here. This is where I call it Disney World because it's a happy place. Quadrant 2, we go backwards, counterclockwise, which is a negative, positive. Okay, the first number is negative, second number is positive. Quadrant 3 is down here, and this is Grumpy Land because it's negative, negative, negative X number, negative Y number. And quadrant 4 is a positive number with a negative number. So number 1, it says identify the ordered pair that names point C, then identify the quadrant in which it's located. So we're going to start to the 0. We're always going to start here in the origin, which is 0. And we want to find point C. So we're going to move on the x-axis first. So we want to find x first. And then we're going to find our y. So x always moves left to right. Y always moves up and down. So I'm going to go to the right because C is over here on the right. I'm going to move over to the right and stop on that same line. So when I moved on the line down here, my x value is 1.5. My y value then, how high is it? So if I draw my line to C, I go over and it's at 1. So you always have to do your x first, then your y value. So x left and right first, then go up or down. So my coordinates for C, or its address for that house, is 1.5, 1. So identify the ordered pair that names point A, and then identify the quadrant. So point A is here. So I'm going to start here at 0. Remember, we have to go x first and then y. So here's x goes left to right. I'm going to go over here till I go and find A is at -1. So how high up is A? So from here, I'm going to draw a line to the y-axis, and it's at 1.5. So there's my quadrant, -1 and up 1.5. So which quadrant is that in? Well, if you remember, 1 is here, 2, because we got to go counterclockwise, 3, and 4, we are in quadrant 2. Refer to example number 1. Here's our example. Identify the point located at 1, -2. So in this case, I have to go and I've got to find the house. So here's my x value, here's my y value. So we're going to go to my x value first. So I'm going to start at 0 and I'm going to go to 1. So here's 1. Then I want to go up or down to y, which is -2. So I go down to -2, which is here. So whose house is here? That's E. What quadrant is it located in? It's located in 4. So when you find your letter, draw your points to the x-axis and over to the y-axis. When you're finding an address, start at 0, go to that first number left or right, and then draw a line up or down to the second number. Reflections on a coordinate plane. You can use what you know about number lines and opposites to compare locations on a coordinate plane. Consider the number line and coordinate plane below. The number line shows that -4 and 4 are opposites. The coordinate plane shows that the points -4, 0 and 4, 0 are the same distance from the y-axis in opposite directions. So they are reflected across the y-axis. Notice that the y-coordinate did not change and the x-coordinates are the opposites. So I wrote down over here that I hope you write down in your notes something that helps me remember. When you reflect across the x-axis, x stays the same. And when you reflect across the y-axis, when you reflect across the x-axis, x stays the same and the y changes to its opposite. So when you reflect across the y-axis, y will stay the same and the x changes to its opposite. Follow these rules to help reflect across the x and the y axis. So we want to name the ordered pair that is a reflection of -3, 2 across the x-axis. So here's my address. It's -3, 2. Here's my x, here's my y. And we want to reflect across the x-axis. Okay, so we just said that when we reflect across the x-axis, the x stays the same. So when I find its reflection, x stays the same, that's -3. What happens to y? Y changes to its opposite. So like I said, here is -3, 2. There's -3, 2. We want to find the opposite of that across the x-axis. So it's got to be down here somewhere. So the opposite across this line, when it go down to this line, everything changes. So it's the opposite of opposite of 2, which is -2. So the opposite is here. That's the reflection across the x-axis because we want to cross the x-axis to find it. Let's name the ordered pairs that reflect across each point of the x-axis. So again, when we reflect across the x-axis, x stays the same and y changes to its opposite. So here's my x value, here's my y. X, y, x, y. When I reflect across the x-axis, x stays the same. So in letter C, x stays the same, which is 1. Y changes to its opposite, -4. The opposite of -4 is a +4. Letter D, -2, 5. X stays the same because we're reflecting across the x-axis. It has to stay the same. What happens to the y? Changes to its opposite. What's the opposite of 5? That's going to be -5. And letter E, x is -3, so x stays the same. Y changes to its opposite, the opposite of -1 is 1.